This is a revision session for OCR FP1. The topic is series and the question is January 2010, question 4. So the question asks us to find the sum from r equals 1 to n of r upon r plus 1 upon r minus 2, expressing our answer in a fully factorised form. So the first thing we need to realise is that we can multiply out these brackets to get sigma r cubed minus r squared minus 2r. All of these sums are from 1 to n. But not only that, we can actually split these summation signs, and so it'll be sigma r cubed minus sigma r squared minus 2 lots of sigma r. And again, all of these from 1 to n. So what we need to do now is to try using sigma r cubed minus sigma r squared minus 2 sigma r, using the formulas which we've either learnt or in the formula book. So the important thing is that to remember is that sigma r cubed and sigma r squared are in the formula books. I've put them down here. So these are the two that you would look up in your formula book. But sigma r you should learn, and it's not given to you, so you need to know that sigma r is a half of n upon n plus 1. So what we're going to do now is just to substitute those in, and then, as I say, we have to give our answer in a fully factorised form. So sigma r cubed is n squared upon n plus 1 all squared over 4, or a quarter n squared, whichever you prefer. Sigma r squared is n over 6 upon n plus 1 upon 2n plus 1, and then 2 sigma r will just be n upon n plus 1, so the 2's cancel out. So we have that now, and we now have to simplify this expression on the right hand side. So we look for common factors. Not only do we look for common factors in terms of n and n plus 1, but we want to try and take out the fractions. So we have a quarter and a sixth, so the easiest thing to do is to take out a 12th. We then have an n here and an n here and an n here, so n is a common factor, and we have an n plus 1 and an n plus 1 and an n plus 1, so n plus 1 is also a common factor. So don't sort of try multiplying out, because that really is a backward step. The trick at this stage is always to look for common factors. So we've taken out a common factor of n upon n plus 1 over 12, so we still will need an n and an n plus 1 for this first term. But not only that, we had a 4 in the denominator, and here we've got a 12, so we must put in a 3. Similarly, when we go to the next term, we have n over 6, so here we had a 12, so we will need to have a 2. The n and the n plus 1 we've already taken out as common factors, so that leaves us with a 2n plus 1. And then we just need to be careful here. We've got an n upon n plus 1, so both of those have been taken out as common factors, but of course we've also taken out a 1/12, so we will need to have a minus 12 here. So it's always worth checking at that stage that you know, if you multiply out those brackets again, that you get back to where you started. So let's now multiply and simplify what's inside our square brackets. And we end up with a 3n squared there. We've got a 3n and a minus 4n there, so that will be minus n. And then we have a minus 2 and a minus 12, which is minus 14. Now at that stage, look at the quadratic and hopefully it will factorise. Sometimes it won't, but in this case you should see that in actual fact it will factorise as 3n minus 7 upon n plus 2. And we now have our answer, so all of this, bear in mind, is over 2. So we have our answer in a fully factorised form. So just looking at how the marks are awarded for this, you do get a method mark for seeing that you can express it as 3 series. You get a method mark for substituting in and using the standard results, and an accuracy mark if you do this correctly. You then get a method mark for taking or attempting to factorise, and an accuracy mark if you've taken out at least n upon n plus 1 here, you'll get an accuracy mark, and then you'll get another accuracy mark right at the end if you've got it fully correctly factorised. So 6 marks in total for the question. So don't forget there are plenty more revision videos available if you go to the Further Maths website.